QA for the reverse engineering module of pwn.college. I'm trying to turn off this fucking doorbell in the class, so you'll have to bear with me for a second. Zoom decided to log out on my iPad right this moment. Okay, one sec. Meetings. Meeting settings. Turn off the fucking doorbell. Okay, good. Fuck. What the hell? Okay, anyways, let's also tweet to let people know we're on, and then we'll actually start. Okay, let's roll. One more thing, I have to connect. Man, there's so much stuff to do for this streamer life. To connect. Boom, alright. Oh, the mic sounds far away because it is far away. Let me move it. It was in my alternate position. No one told me it was far away. There we go. Is that better? Okay, awesome. All right, let's roll. So, we were going to in this Q&A, we're going to dive deeper into reverse engineering. First, of course, let's start with our state of the class, just kind of to catch everybody up on where we are and where we're going. No, what the hell? There we go. Hit the wrong button. All right, we are in week 5. So originally this was going to be the start of the memory corruption module, but since everything kind of builds off of reverse engineering, we're still on the reverse engineering module for another week. So give another week of, let people understand and master reverse engineering. We'll upload a couple extra challenges. It'll be all sorts of good fun. Someone on Twitch asked if I got a haircut. I did not get a haircut. I just look really good sometimes. All right, let's roll on. So, meme highlights. There are some good memes this time. I really appreciate these memes hating on AT&T assembly, the incorrect assembly format, of course. That's really good. You should all know to, what is the right and wrong assembly format. There is a right and wrong assembly format for x86, and the wrong one is AT&T assembly. Awesome. Some good memes on, the various viewpoints on reverse engineering. Some people that this is a good kind of old school meme. I like that. This was good when I released Jan 85, and then started working on more challenges. Basically, what happened was we were going to launch 16. I think we were going to launch 15 challenges, maybe even. Connor, do you remember? Is Connor even alive? There was a good meme about Connor holding up the server single-handedly right here. That he might be still dead from that. Is Connor like speaking on Twitch or on Zoom, and I can't hear him somehow? Who is on Zoom? Only 35 people on Zoom. Oh, tisk. All right. Anyways, we'll move on without poor Connor. Rip. All right. So, some good series meme right here. Basically, we started out wanting to release 15 challenges, and this was gonna be we were gonna add to the my mind just went blank. Oh yeah, this was gonna include the keygen challenges, the crack me challenges, like the patcher challenges, and the VM challenges. And then basically we ended up with 17 challenges because while writing Jan 85, I had this idea of this completely blind reverse engineering challenge that you now some of you have pulled off. So that was pretty cool, and that became level 17, and then several people let me know that I actually screwed up level 17, and then we created level 18. And I posted, when I announced it, told people how you can see the difference and the screw up of level 17 by comparing the imported symbols. So that's this story. It's a good story, kind of story of our age, so to say, or story of this module. This was pretty good. People were about to go to bed when we announced that we were soon releasing 15, 16, and 17. And of course, it's a little tricky, the process of releasing these challenges, of creating these challenges, because you have to solve these challenges, right? And that's tricky, and you know how tricky it can be. The challenges are all generated slightly unique for every person, for every variant, right? So, testing 1, when there's going to be testing 2 and so forth, testing 1 is different from testing 2. The teaching is differently randomized from the testing, and the randomization is different between students. You have to solve your version. We have to solve every single one, because when we synthesize them, we have to make sure that they're actually solvable. So this is a little tricky. Question on Twitch: do we need Pwn tools for the later challenges? I would highly recommend Pwn tools. Just master it. It's one thing that Connor and I have been discussing is creating like an IPython notebook interface for you, so you can just click like start Pwn tool script or something. But in the meantime, just use Pwn tools. All right, I'm actually seeing some people talking about not having used Pwn tools that are pretty high up the scoreboard. So I'm surprised that people can get that high up without using Pwn tools, but Pwn tools will help a lot. Someone discovered anger in the course of doing these challenges. That is awesome. Anger is definitely a help on these. Maybe if you have time, I'll go through it a little bit. All right. One set of kind of concerning memes is people that seem to be sacrificing other classes to for the sake of 466. I am not sure how I feel about this. It's probably not a good thing. There's a question on 2 questions on Zoom. One question is, does Jan prefer Ghidra or Binary Ninja? So I'll be honest, I prefer Ida. Ghidra is probably I haven't used Ghidra a lot. Ghidra is extremely capable. It's just I learned on Ida, and Ida is, in some sense still the gold standard. So if you have, if you're able to use the community edition of Ida, use the community edition of Ida. It's quite good. Yeah, on Twitch, someone's requesting Ida Pro. That's going to be hard. But like I said, there's various community editions of it. Interestingly, someone on Twitch saying that Ida cannot resolve indirect jumps for the Jan 85 emulator, but Binary Ninja can. So that is very cool, right? So another option is look at things in all the different platforms, or all the different tools, right? Ghidra costs you nothing to install Ghidra. It's free and open source. Binary Ninja Cloud is free. Ida is free for their community edition. So, try out all three if something is very, very confusing. Another question is, how close can reverse engineering get to recovering source code accurately? It can get amazingly close. There are two... It's very hard to get close, but you can do it. There's a success story called OpenTTD. OpenTTD is an open source reimplementation of a game called Transport Tycoon Deluxe. I highly recommend it. We should actually, maybe it's time to start endorsing products on this stream. That would be good. But anyways, if I were to endorse a product, I would endorse OpenTTD. It is a very fun game where you build a transportation system to transport goods. Why are we talking about this in a hacking course? Because the way that OpenTTD came about is they took the Transport Tycoon Deluxe binary, which was an old DOS game. I actually have it in a box here. They took that game and they basically dumped the disassembly and they hand decompiled it. And that's how they generated what is kind of the original source code, or something very close to it, to the point where OpenTTD is interoperable with things created for the original TTD. So that's a very interesting success story of someone taking binary code and using that binary code to essentially give new life to this game, which is awesome. Cool. I used to play TTD like heavily every year. Once a year, I would go and play it for a couple of days. Kind of fell out of the habit around the time I hit grad school and ran out of time to do anything. But through high school, undergrad, it was really awesome. Cool. Someone says on Twitch, Roller Coaster Tycoon 3 is free on Epic Games tomorrow. That's also a very good one from the same person that made Transport Tycoon. Fun fact, by the way, Transport Tycoon, actually I don't think this is true of Roller Coaster Tycoon 3, but Transport Tycoon and Roller Coaster Tycoon 1 and 2 were written in raw x86 assembly by this crazy amazing person that wrote them. So you're like, why should I, write raw assembly? Chris Sawyer wrote Transport Tycoon in x86 assembly. You search assembly, well, it shows up in the category assembly language software, but for sure, Transport Tycoon was written in assembly. It's amazing. Very, very cool stuff by Chris Sawyer. Anyways, that's enough. Probably that is sufficient endorsement to earn their sponsorship money, so that's pretty good. Okay. Someone asked on Twitch, why x86 assembly? it's just cooler that way, man. I mean, you can use C or like Python or Java, or you can use x86 assembly, and that really separates the elite from the noob in some sense. Probably it's a terrible idea, by the way, and you shouldn't do it, but you know, it really makes you get kind of down to basics and so forth. All right. What's next? CTF report this time. This past weekend, we had 19 CTF extra credit reports. A couple of you are waiting on a response from me. We kind of stopped acting because there are just so many emails. So there are 2 people that are waiting for me to act. They specifically requested, "Hey, did you get this?" We did, and if we didn't, don't panic. We'll figure it out. We're working on getting this on the scoreboard, and we will. So on the scoreboard, you'll have little like flares for the CTFs you played, and then we'll add that in your grades. People have asked. This topic keeps coming up. I didn't think to put it in the slide of a certificate for completing pwn.college for all the non-ASU students. We are working on something like that, and we will, of course, give extra credit for CTFs for that as well. Don't send us the write-ups yet. We'll try to have something ASAP where you can just, instead of emailing us write-ups, everyone should hopefully be able to submit it through the website, and then you get some flares or something. We'll figure it out. It'll be awesome. Connor doesn't know I'm saying any of this and is probably horrified at, it's the typical sales department is like making promises that devs are going to have to implement. But we'll figure it out. Awesome. Okay. Then, everyone's wanting an OO t-shirt one day when we retire, or people catch me at a kind of slightly mentally decision impaired state again. T-shirts will be distributed one day. All right. So basically, the awesome thing this time is 12 challenges. A union of 12 challenges were solved by the students. Of course, that's across 2 CTFs, so there were more kind of easy challenges, but Down Under CTF seems to have been an awesome CTF for intro players, to the point where I actually, after reading this feedback over and over and over in the write-ups, and yes, I read every write-up, I went and reached out to the Down Under CTF organizers and let them know that my students loved it and it was super useful. So awesome stuff. Someone on Zoom's asking if Pwn Devils is open to alumni or only current students. It's open to alumni. It's open to everybody, actually. Just show up on the Discord and start chatting. Feedback on Twitch, other than some memeing going on, is that people really like DU CTF. That's awesome stuff. All right. Remember, going forward, keep sending in those write-ups. There's a strict 4-person minimum for if you're not playing with Shellfish. This is because I don't want you to sit there alone, lost, and demotivated. Make sure to submit individual write-ups and keep the write-up quality high. Awesome. All right. Let's see where we are in terms of ASU versus the world. This is the first week where the world took first place. Congratulations, Hollow Circuit. You're currently in first place on pwn.college, and the kind of top of the scoreboard is becoming more and more exclusive. In order to get into the top 9 now, you need to solve, or before, if you look at last week's situation, if you solved everything, that's still only like top 20 or something. Right now, if you solve everything, you'll get into the top 10. That's awesome, tweak of the grade distribution, and soon we'll see on the next slide that the number of A pluses is decreasing slowly, and that's fine. But you can still do it if you put your mind to it. I think that's a song somewhere. Anyways, awesome stuff. Some other changes on the scoreboard. Neural skyrocketed into second place. And then there's some familiar names, O1, and a new name, Propio. Actually, I have to call out Propio, who was the first to solve level 17 and make it to the top of the scoreboard. Then level 18, Hollow Circuit sniped that out. And then Zeros moved up. Well, no, actually, Zero slipped a little bit, but you'll get there. And then we have kind of a lot of the existing suspects toward the top of the scoreboard. Awesome stuff. Good to see people fighting hard. Let's keep going. The current grades, of course, things are looking much worse for the reversing challenges than they did for previous challenges, and this is why we extended the module. Basically, we have the majority of the class still at a failing rate on these modules. So that's not great. Hopefully, with one more week and more Q&A and more office hours, we can get better results, right? I think only like 6 ASU students have so far solved the level 18, but we'll get there. All right. Someone's saying, who is number 75? I have a feeling it's going to be L1R PHX. All right. Cool. So, what if you are here? If you are really struggling with reversing, one, keep pushing. You have another week, a whole extra week. We're going to go through some strategies on chat here. We're going to have a long collaboration hour, and then we're going to we're moving Connor's office hours to Friday instead of Tuesday, so that there's more time between his office hours and the deadline for you to put that knowledge into practice. So there's going to be, there will be a total of 3 office hours and this extended lecture today, for this week rather, and then for this module you're going to end up with like 1, 2, 3, 4, 4 office hours and 2 extended lectures, or 5 office hours and 2 extended lectures. So hopefully that will help a lot. All right, we are still kind of at a slight curve. You notice I'm not curving and will not curve A pluses and A's. Slight curve on B's, C's, and D's if class were to end today, but this curve can decrease and hopefully will decrease as people do better. All right, what to do if you're really struggling? One, take advantage of this extension of the reverse engineering module. Question on Zoom: can we access the office hours that were already held this week? Yes. You can access it on Twitch. I'll send out this announcement. You can access it on Twitch, and you can we'll be uploading everything to YouTube, or have uploaded everything to YouTube. So both of those platforms will have the office hours. Go through them. Someone actually earlier said, can we have a tutorial on using pwn tools? Connor does that in office hours. I think his first office hours were mostly all about pwn tools. So go check that out. All right. Then, second thing, don't panic. We'll all get there. Not all of us will survive, but hopefully most of us will, and it'll be awesome. 3, don't forget, even after the deadline, challenges are still worth half points. If you are one of the, I don't know if these people exist actually, but if you solve all of the reverse engineering this week and you still have time and you haven't solved something before, go back for it. You can still ask for help in the help channels. And we'll have 2 weeks on the schedule where there's nothing due. One is voting week and one is like the last week of class, or the week after, between the last week of class and when grades are due. Those will both be make-up weeks with, a lot of collaboration sessions and so forth. There is still a lot of CTF extra credit to get. You can still get 10% extra credit. That is an entire letter grade almost. Of course, the curve would spread out or increase the spread of every letter grade, but that's still a lot of extra credit. And worst case scenario, if you email me before October 1st and request this, you can go to a Y grade grading option. So this is something that, as far as I can tell, ASU invented to help students that are impacted by the insanity around the pandemic. A Y grade means C or better. So if you switch to the Y grade grading system and you get a C or better, you receive a Y. If you don't get a C or better, you get some equivalent of no credit, right? My understanding, and you should confirm all of this, is a Y grade does not impact your GPA, and still counts for some requirements. I don't know if it'll count for a cybersecurity concentration requirement for the ASU students or whatnot, but you can ask your academic advisor and they will know. Cool. There's another question. Is this class impacted by ASU's announcement to skip finals week? No, because we don't have a finals. I don't think that ASU's announcement of skipping finals week impacts when grades are due. And I will leave. We do need some time to get the grades ready, but we've been automating quite a lot of that. But still, we need time to double check and so forth. So probably what we'll do is, for essentially what would have been finals week, we will leave the collaboration. We'll have tons of collaboration sessions, and we'll have the challenges available, and you'll be able to catch up as much as you can to improve your grade. And we'll leave that going up until the night before grades are due, just to give us that morning or I guess that night to calculate grades. How much of the server storage have we used up is a question on Twitch. Did Connor show up? Is he like asleep? Connor told me in my ear that he forgot about all this. He said we haven't used that much space. So don't worry. You can still I don't know if you have the numbers for bandwidth usage. Do we, Connor? Probably not. They're not that advanced. All we track is every syscall you ever made and your what's it called? Your files. All right. Cool. So Connor, since you just woke up, you didn't hear me the sales department promising all sorts of features. But that's okay. You can watch the VOD to figure out what we're going to be on the hook for. All right. Someone so to those asking on Twitch, Connor exists in my ear at the moment, which is good arrangement. All right. Schedule. So we extended the binary reverse engineering by 1 week. Hold on, I got confused. Yeah, okay, we're good. We extended by 1 week. What does this mean? We moved the rest of the course down and eliminated format strings. So format strings are a niche topic. I was already getting shit from some friends that I even teach format strings. They're like, what is this? 2003. So we're going to skip over format strings. Honestly, it is a rapidly dying vulnerability class. It's a cool vulnerability class, and the materials from 2 years ago, because we also skipped format strings last year for actually a very similar reason. I think we had to extend some module. The materials are online if you're interested, but we are going to leave format strings, give format strings a break this year as well. What does this mean? So this means that basically the 4 modules of the course get shifted. And someone asked, when is voting week? If you're an American, voting week is this 11/04. There'll be a guest lecture. I owe some people responses that have reached out for a guest lecture. Should try to get someone like, I don't know, who's super hip and famous and non-controversial. Steve Wozniak. Maybe that would be good. we could get like Weird Al. That would be cool. Guest lecture by Weird Al. Anyways, we'll think of it. Yeah, again, there won't be anything due on the day after voting day. So voting day is the 3rd. If you are an American and if you're eligible to vote in America, make sure to register. Make sure to vote. Please do it. Otherwise, I don't know. You should do it. All right. Moving on. That's it. That's the last slide for state of the class. So then we're going to roll into basically several different approaches to reverse engineering. I was going to make individual videos of this, but instead what we're going to do is record it all here and then split it into videos and put them up as individual videos on YouTube later. Excuse me. I mean, we also put the full recording of the course. Before we get started, any specific small questions about reverse engineering? All right. Oh, there's one question. Will new challenges be more Jan 85? I think one of the new challenges will likely be Jan 85. But don't worry. Even if they aren't, if you miss Jan 85, this wildcard slot 1, realistic exploitation scenarios, will have, basically this is a combination of what we will have learned until then. So like everything through memory corruption and the combinations thereof, there will be some Jan 85 there. You'll have to like exploit through a memory corruption. It'll be awesome. Another question, what kind of side channel should we look into for 17 and 18? Basically, what you want is to understand, is to get what you should ask yourself is, what's the smallest and most guessable thing you can do? Because Jan 85, challenge level 18 and 17, your mapping for the architecture is random, right? If you look and trace through, it uses rand to determine the order of the register encodings, the order of the operation, the operator encoding, and so forth. So there's going to be some sort of guessing. Someone in my ear just said, sounds like a brute force to me. Yeah. But if you do the math, brute forcing the entire layout of everything all at once, that is quite a lot of combinations. So the question is there a smaller thing you can brute force that will give you some sort of signal, like a yes or no, a single bit that you got it correct? What is the smallest thing you can brute force out of that? And once you know that, you can brute force that small thing, and now you have some information. And given that information, now there's going to be another small thing that you can brute force, because you know little information snippet A, you'll be able to brute force using the knowledge of A, some information snippet B. Then you'll be able to brute force some information snippet C, and so forth, right? And it's important in these cases to keep in mind what you don't know. You don't know the order of the register encodings. You don't know the order of the what's it called? The instruction encoding, basically, the operator encoding. You don't know the order of the syscall encoding. And there's a fourth thing that I forgot. Oh, and you don't know the order of the flag encoding. So some of those, that's the four major pieces of information. And then, of course, you can split that out even further. That you don't know the, encoding of register A, you don't know encoding of register B, you don't know the encoding of register C, and so on. There are ways to side channel that information bit by bit. Someone on Zoom asks, could we technically write a script to generate every script ever, or every program ever? Yes, Connor's research project is exactly this in our lab. But more intelligently. It's going to be, it is obviously infeasible computationally to generate every script ever. There is an infinite amount of them. It's if you imagine programming as a multi-dimensional space, every program starting from the entry point, having every choice that you can make at every line of the program, having a new path through this multi-dimensional space. You're never going to explore that fully, but if you have some idea of your goal and some idea of what steps to take along the way, you might be able to synthesize programs intelligently. So cool research area, and but it's definitely out of scope for this course. Cool. All right. Then let's dive into a couple of specific reverse engineering examples using our challenges, of course, and we'll go from there, unless someone has other concrete questions. Oh, on Twitch, someone said, doing 1718 based on electromagnetic radiation. Don't do that. Throughout a couple of extra kind of hints on 1718. Throughout the other challenges, 14, 15, 16, and so on, you've already dealt with randomization of the VM, right? Just not blind. And different signals that VM can output. I don't mean like signals like sigkill and sigint and so forth. I mean signals as in like observations that you can make. You've likely made observations of different behavior. You can utilize those observations in trying to induce that behavior for 17 and 18. That's thing one. Thing two, you can actually write the same attack against level 15 or level 16, right? You can make the same attack, write the same attack against an emulator that you have already reversed, that you don't have to reverse blindly. And this can help you radically in debugging your attack, because you know what the right answer is. And you can write a script to arrive at that right answer. Zero on Twitch asks, I tried solving a crack me that used JIT. Will we go through JIT? So I've mentioned JIT in the past. You might see JIT in this course very soon. Are we allowed to collaborate on RE challenges with other classmates? You are allowed to so we'll have a collaboration hour, probably a collaboration hour and a half today. So you are allowed to collaborate with other classmates then. After that, only high-level help in the help channels. You're not allowed to collaborate directly. But high-level help in the help channels, totally fine. Everything in the help channels until now has been more or less okay. We'll let you know if things are getting too hinty. We've kind of approached that barrier, but not quite past it yet. Except for that one meme. There was a very helpful meme, but even then, all I did is say, hey, that's a little too helpful, and that's fine. All right, so let's dive into some reversing. So I'm going to start with demonstrating one specific thing, and that specific thing, let me see if I have this. What do I have downloaded here? Okay, no, I need a different. What should we solve? Let's do level 3. Connor, level 3 has manglers, or only level 4? Level 3 has. Yeah. All right. So let's do level 3 testing 1. We'll start with that. All right. Open it up in Binary Ninja. All right, I want to show you, and I kind of brushed over this in office hours, but I want to show you how to merge in your mind static and dynamic analysis. It's an important thing to be able to do, and the way to do it is, again, in your mind, or as some of my students were talking about on Discord, using the Cutter reverse engineering tool. I'm going to give them a quick shout out. Cutter is Cutter is a part of the Radar 2 project, which is a reverse engineering platform. It is another tool like Binary Ninja, Ghidra, IDA, Anger Management, Cutter, right? Go to cutter.re. Cutter has a seemingly pretty good, I've never used Cutter, but my students are saying that it has a good simulation engine where you can actually combine static and dynamic analysis in one interface. Today, I'll talk about using Binary Ninja and GDB side by side. So, let's say we started, we just opened it up here. We see our underscore start. Let's see. Hopefully this won't cause problems with the graph layout. All right. And I'm going to also open up GDB. So I'm going to SCP to my local machine. That challenge. All right. Wait, what? Oh, I didn't launch it. Wrong one. Let's launch it. Practice mode as well. All right, level 3 testing 1. And I'm going to launch it in GDB. All right. So one thing that you'll notice, this is vanilla GDB. Actually, for the purposes of this of this video, let me just install pwn GDB, pwn debug. Sorry. Yeah. Oh, really? By default? Oh, okay. Okay, so I'm going to actually show on the server something very awesome. SSHing in, and I will show you something that'll hopefully blow everyone's minds. Connor has installed pwn.debug on the server. What you do is copy from opt/pwn.debug. .gdb init. All right. So this is kind of a skeleton directory of configurations. This is the GDB init that basically Connor's now infected us with. What is splitmind? Really interesting. What about screen? All right, so Connor says splitmind is a GDB plugin that will integrate nicely with tmux. So check that out as well. I guess this is what this splitmind stuff does. Anyways, let's run GDB with baby rev. And here you can see this looks totally different. Looks very, very spiffied up. pwn.debug has an entry. No, it doesn't. What am I saying? We start the program. And we are now rolling, right? So right here, you can see quite a lot more information. Unfortunately, it looks kind of like a little crappy on my screen because I have to scroll up. But this gives you a lot of information that otherwise you have to keep either displaying by yourself or examining by yourself or printing by yourself. It gives you the state of the registers every time you stop execution, including some intelligent analysis of what is where things are pointing to and so forth. So in RDX, right in the beginning here, this is the third argument of to main. We have a pointer. This is env that points to env0 that points to this challenge ID 161. RSI is argv that points to argv0 that points to our argv0 string. RDI is the number of arguments. That's 1. So it's much more useful, right, than just vanilla GDB. All right, I believe we also have a base variable here. No, dang it. So the base variable is still not so good for us, but it's fine. We'll handle it our own way. Okay. So you can see, actually, you can now do VM map. It's a nice spiffier output of info-proc map with some annotations, color annotations. That's very cool. All right, so we can set this as the base. And one reason that I would recommend actually doing the debugging off server is we still haven't gotten ASLR disablement working on the server yet. We're oh, really? Okay, so here's our base address. Yeah, so Connor just told me pwn.debug has PyBase. I've never had to. I have my own base set in my GDB init. Can we do PyBase as a variable? No. Any idea, Connor, on how to calculate offsets from PyBase? Oh, sweet. So if we type PyBase and an offset, so over here, if we switch back into the browser, here we have the offset of start into the file, or we can look at the offset of main into the file. So here's main. This is all of our logic that we're going to reverse in a second using a combination of static and dynamic techniques. And main is at offset hex 1229 in the file. If we 1229, Awesome. So can we do a break? Well, how do we do this? Obviously, this is likely not it. No. How about set? No. Obviously, that's not GDB syntax. Let's do some Googling. I like my base variable. It looks like there's a PR. Rebase. Yes. Boom. Oh, shit. Thank you. So, there's a function in pwn.debug called rebase that will make your life nice and easy. This is the rebased address in memory of this 1229 in main. Very cool. So if we go here, and now we can do, examine the instructions. There's that NBR64 instruction. And we can set breakpoints, which will become important in a second. First, we're going to reverse engineer some stuff to kind of start us on our journey. All right. Now the control. Okay, will this work? Yes. Okay. All right. So here we go. This is baby key testing, baby rev level 3 testing 1. We used to call, or internally we call these key gen 1s baby key. And what I'm going to stress heavily is that I'm not going to read step by step every assembly instruction. That's crazy. I'm going to stare at this graph. I'm going to get a high level understanding. And then I'm going to dig in the assembly and using dynamic analysis using GDB when I need to. Okay? So let's, for example, just skim until we see ready to receive your license key. All right? Obviously, if we switch back to the terminal and we actually run this, /baby rev level 3. Okay, ready to receive the license key, and then an assertion that is failing. All right, so obviously it is receiving our license key. Boom, ready to receive your license key. Usually, unless you're reversing tricksy CTF challenges, this sort of print statements and so forth are trustworthy. Right, so it'll help you understand what is going on. All right, then we do some checks on something, and then jump. Or no, we set up some variables and then jump, and it looks like we jump into a loop. So this whole thing is a loop, right? And the loop calls stern comp. So notice I didn't go instruction by instruction loop. I'm still staying kind of high level. Calls stern comp on this SMNDF, which is the second argument. And then the first argument is something. But in combination with SMNDF and the error that we saw just now in the command line that we can find here, input NP not equal to 0, we can guess. So stern comp returns non-zero when it is or returns 0 when it finds something. The error is an assertion failed that the input is not 0. That doesn't actually quite match up, but let's keep pretending. So we can see there's something to do with the environment, something to do with stern comp, and something to do with SMNDF. 3 pieces of information that you combine up here to say, hey, to build a hypothesis. And your hypothesis is maybe this program takes input over the environment with SMNDF, right? So then we say, okay, SMNDF equals ASDF. Oops, not pipe it in. And suddenly the behavior is different, right? So without reading the assembly line by line, without going through and figuring out where does RDI come from, where does RAX come from, RAX is dereferencing something, where does this come from, what is var 50, by using error messages that the program spit out at us and kind of common sense and intuition, we already reverse engineered oh gosh darn it. We already reverse engineered this entire part of the program, right? So that's half of the program, and we didn't even touch GDB yet. That's pretty incredible, right? I think so. Okay, cool. So now we've avoided this. We're no longer exiting with this stern MP is not equal to 0. That means we're here. All right, now things get tricky. We can see eventually it'll check the received license key, and here's that str and comp against the expected result. Okay, no problem. That is very straightforward. We've seen this before. We double click on here. This is the expected result. Clash X RQF. So that's what we need to get, and then the question is, what is the mangler doing? And I realized that I am actually just repeating what I did in office hours because we already reversed this exact binary. So let's pause here and let's open the next level to try to apply what we just did with this input to the next level, right? How we determined how to do the input. All right, let's pull up level 4 testing 1. Spin it up and inspect it in Binary Ninja. All right. Go to main, and same sort of thing here, right? We see something WVFNN. At this point, we can recognize it as probably some sort of a input key, and it calls open, and it does an lseek, and then it does a read. That's pretty simple. Of course, here input FD is greater than 0 after the open. That checks if the open failed. So it seems that it's just trying to open something. Nice and straightforward. That, of course, we can also strace. So if we strace baby key rev level 4, we can see this open and it fails. All right, so that's even easier. Just a file, right? So we can do echo hi to WVFNN. Up. We see it's opening it at the home the current directory, just local directory file. So we just change directory and do that. Awesome. Now we run it, and at least it reads the flag. All right. Again, did I click through every single instruction? No. I looked at it in broad strokes and understood. That is what very high-level reversers, if you ever watch my colleague Fish reverse, he does this unbelievably fast. He'll click into a function, skim, okay, that's what this does, and so forth. He makes assumptions, and then if those assumptions are violated, he later goes and fixes them. But he makes assumptions, he builds up an understanding of the program, and keeps moving. All right. What does this mean past that? All right, so now it does something, again, something more complicated, and then checks the license key against, again, the expected result, which is BCCF GIP. I'm going to copy that off so that we can refer to it later. Awesome. So that's our desired value. And what happens to that value is this loop. So this loop compares, it's a loop on a variable, and it will keep looping until that variable hits OX6. So this is some sort of a counter. It will keep taking this jump. This is the green taken path, as long as this variable is less than or equal to 6. So this is a counter, and we can set a comment here. Iterates 7 times. 0, 1, 2, 3, 4, 5, 6. Cool. Someone on Twitch, on Zoom, is asking, how do we pipe NFP to a program? That is nice and easy to do in Bash. You do key equals value. This is key is the name of your argument, value is the value of it, and then your command. This one doesn't take input over through the environment variable. So this one just runs and takes input from that file. All right. Cool. All right. So then we have this monstrosity. Do we really feel like reversing it by hand? We can, but we can also, there's a number of things we can do. We can try to reverse this by hand, instruction by instruction. We can try to understand try to pattern match and recognize that this looks mighty similar to something we've seen before on level 3. That this is a swap operation. Or let's take the third route. We can run through it in a debugger and see where that takes us. So let's take that route first. I'm gonna generate an input that we'll use to just see where data goes. So if you import string.printable, these are all the printable variables that we can use as our input, and we can just copy a bunch. Then later on we can actually use. So if we do, our input is this, right? And later on, some register contains the character 6. We can do something like index 6 and figure out, let's do something more interesting. Index A, figure out that A is the 10th character of that string, so that might be where it came from. All right, let's take a look here. So we're looking at our, all right, and this is what we'll write. Awesome. So now we GDB, and then we we start. Entry break is, I think, a Jeff mapping. I bounce between these too much. All right. Now what? Now we want to break right here to start right here at the beginning of this iteration to try to understand what the hell is going on. So let's take a look. Now we can break at rebase that. Okay, we run, and here we are. We are at, where are we? What? Is this thing? Did the program die? Break. Oh, I hit R instead of C. And then we continue. We were already running. Then we continue to our breakpoint. Okay. Here we are at this comparison. And it compares this value against 6. Let's see what RBP minus hex 20 is. 0. All right. So this counter, so we now, we didn't actually know that the counter starts at 0 because I didn't actually look a little bit ahead and see that that's how it initializes, but that makes sense. So I just assumed it started at 0, but it's nice to see that validated. And then one thing that we can do is step by step see what in the first iteration, what values all of these variables hold. Okay? So let's step until we are at this first unknown variable here, which is, and that'll be 1420. Okay? So step. This is annoying that I have to scroll. Step. All right, we're at 1420. We have a local variable RBP minus OX1C. Let's see what that is. Let's see, what kind of a read is this? This is a D word pointer, so it is not G, it's a D word. What is the hell? Okay, that's correct. X. Okay. That is 0. Okay, so this starts out as 0, and in fact, sorry, I had a brain fart. In fact, it's also initializing it to 0. Okay. Let's switch back to the static real quick. All right, this starts out at 0, and then seemingly it is compared against something. It is red. It is red. It is red. Nope, wrong thing. It is red. It is red. It is red. It is red, and it is incremented. So this might be another counter, right? So let's say another counter, and in fact, this other counter is compared against this EAX, and EAX is 7 minus this is a hypothesis that it's another counter. EAX is 7 minus the counter itself, right? So this gets set to 7 minus. So actually, we might have already violated our hypothesis. And we can say that oh, no, gets compared against. Sorry, thank you. Okay. So it looks like we have some sort of a crazy loop within a loop, and you can actually see that in the graph with one backwards edge, that's this big fat blue edge, and another backwards edge, this big blue edge. So there's a loop within a loop going on. All right. Let's keep stepping. So we're going to step, and we're going to step. And we're gonna, so this is that moving, oops, you can't see me here. This is moving 7 into EAX, and then here we're subtracting it. Okay, from the subtracting the counter from 7, and then we're gonna write that into this other counter situation, and what we're writing into it is EAX. So we can see what is EAX. EAX is 7, as expected. 7 minus 0. All right, let's start stepping. That's main. Step again. That is now this new. This is our old counter. let's look at this in Binary Ninja. It's a little nicer. So here, we're right here. We're going to read our new counter, and then we're doing something here. I don't know what, but we're reading some variable, right? Let's take a look dynamically rather than reverse engineering this all statically. We're going to move to 142E. So we're going to go step twice. Now we're here. We're about to read RBP plus RAX plus 11. Let's see what's there. Minus 11, sorry. That looks familiar, right? 4, 5, 6, 7, 8, 9, lowercase a, lowercase b. As a reminder, this is our file we're talking about right here. All right, so now what did we determine? We determined that this is about to read from our input. Let's actually take one step forward. So what did we just do? We moved something into EDX. Let's see what that is. Hex 34. What is hex 34? 4. All right. So, and now we can just write, hey, this just read 4 on the first loop, right? So this is our input, seemingly. I hate how it jumps around when after you do anything. Okay. And then here, first iteration reads 4. Cool. That is some part into our input. And we know, since it read 4 and every byte of our input is unique, exactly which offset into our input it read. That's already, what the hell? Okay, that's not a great thing to do for a comment. Okay, there. It reads 4. All right, let's keep moving. So now we have EDX that has gotten read 4 out of, and it looks like down here things are going to be compared, which is pretty exciting, against whatever happens here. So let's see what gets read into EAX here. Okay, so we go back to the terminal. So oops. Okay. Here we have, here we're about to read something into EAX. Let's see what got read. 5. Okay, that's great. So here, this first iteration reads 5. Okay. And then it compares 4 and 5. And then if 4 is less than or equal to 5, it will skip over this situation. That's very interesting. Are you joking? We should remember to tell the Binary Ninja guys that this HTML encoding is kind of obnoxious. Cool. All right. So, and then here, if you recall, in office hours, we reversed something that looks very much like this, and this was a swap. Right? Let's actually dive through it real quick. There's a couple of inputs that we are kind of unsure about. We know what is in AL. In AL, there's 4. It's the least significant byte of EAX. So here, this is going to write 4 somewhere. Okay. And then here, what's in DL? In DL is, sorry, in AL is 5 and DL is 4. So this writes 5 somewhere. And this writes 4 somewhere. All right, so now you see I'm building up information. There's some unknowns left. One of them is where the hell is it writing 5, and the other one is where is it writing 4. And then here, what is it writing into our input here? So basically, this is very easy to do. We just step through and we look what is there before, what is there after. Okay, switch back into the browser. So what we're going to do first is figure out what we're overwriting with 5 here. Or actually, even easier, let's take a quick glance. Where's this variable used? RBP minus 22. It is not actually used anywhere else in this entire function except for here. So it is written in here and it is read from here. So let's just assume, all right, it's some temporary variable, right? Temp. It is used to temporarily store something, specifically the number 5. So this actually becomes write 5 to temporary storage, which means, and we can confirm this dynamically, that this will be writing 5 to dx and then be setting it to dl here. All right. So let's actually roll onwards. We want to know where are we storing 4, which is or where are we storing. What is this store doing? First of all, this store is writing AL somewhere. AL gets read, actually, I was wrong before, gets read from here, from our input. So let's take a look. We want to move to 4059. Okay. Step. Okay, hold on. I'm going to zoom this out a little bit. Hopefully that's still readable. And then I have to fix that. Okay. Hopefully this is still readable. This will make it a little easier for us to do. Holler if it's not. All right. So we want to step forward to 1459. Damn it. Looks kind of ugly, but that's fine. 142C. Wait, how are we still here? Something got confused. We're gonna restart. Okay, we're gonna make this breakpoint. We're gonna continue. Okay, awesome. And let's just, does this still work? Oh, does this work like this? We're gonna run until we want 0459. Will this work? Whew, amazing, it works. All right, so we just ran until this. What? Okay, that did not work, obviously. That's oh, I'm a dummy. Let's take a look at what's going on. So I said, okay, we want to get through here. No one stopped me. This compares 4 against 5 and jumps over this if 4 is less than 5. Of course, 4 is less than 5, so we're not even going to get into this situation. Right? So you can already probably predict what we're looking at here, obviously. But let's try to switch 4 and 5 in our input so that we can reverse engineer what this does dynamically. All right, switching back to our input, looking at our input here, let's switch 4 and 5. So let's do 5, 4. So that'll be in ASCII, 5 is still greater than 4 in ASCII. We'll restart. We will run until that rebase. What's going on? Gosh darn it. Let's just break here. Okay, and then run. Ah, shit. That restarts the program. Start, make a breakpoint. Should have just stuck to vanilla GDB. All right, anyways, we are here where we want it to be. We want to understand. So we swapped 4 and 5. So now this will read 5. This will read 4. Because we swapped our input, we changed our input, so let's update these so that we're up to date. This will skip if 5 less than 4, which is not. Cool. All right, then we go here. So here, this AL is now 4. So this writes 4 to temporary storage. Let's just break there to confirm. And this will write 5 somewhere. Cool. Okay, so we're right here. So we're no, we're at 5.9. We're right here. We are moving EAX into EAX from somewhere in our input. Let's take a look. Here, somewhere in our input is again RBP plus RAX minus 11. Let's take a look, and we're reading 1 byte out of it. So let's look at 1 byte. So this is examine 1 character in RBP plus RAX minus hex 11, 4. All right. So this reads 4, moves 4 into RAX. And this writes 4 somewhere. And we determined that that was looks like another temporary store that only ever is used here and here. We can, unfortunately, oh nice, we can scroll all around and see that it's never highlighted again. Does Binary Ninja support IDA like extras? No. That's unfortunate. All right. In IDA, can you in a local variable? In IDA, you can always try to hit X to see what references the variable or whatnot that you're looking at. All right. Or the entity you're looking at. So here we are writing 4 somewhere, and then we immediately read it back out. So this just seems like bad optimization, and into EDX and write 4 somewhere here. So this isn't write 5. We were wrong. This is write 4. Let's confirm that. So where does 5 go? Anyways, let's confirm that in 146A. 146A. All right, let's see what this is, and what RDX is 4, like we thought, and what this is now is 5. So this overwrites 5 with 4. Okay. Interesting. And then it will overwrite something in our input with this temporary store. So what is this temporary store? RBP minus 22. Let's see what's going on here. I pasted something back in. RBP minus x25 is 2. So somewhere here we missed this. Actually wrote 5 to temporary storage. That was wrong. And then here we're going to see 5 being written to this input right here. Let's see what it used to be. 147A. Okay, almost. Here we are at 147A. Doing that right. Minus OX11, 4. And here you can kind of tell, okay, RBP minus OX11 is where this buffer is, and RAX is the index into it. Right, and RAX is 1, so it's indexing 1 into our buffer. So our buffer obviously starts with wherever 5 is, and then which now has been so this is the same. Here's 4, and at the beginning now is the other 4. So this started as 5, 4 as our file, 5, 4, and then ended up 4, 5. Right? All right. And then if we step and look at our buffer as a string, 4, 5, 6, 7, 8, 9. So let's take a look back here and try to deduce what happened if 5 or whatever here is the first byte is less than the second byte. It'll swap them, and it does this in a loop 7 times. Right? This sounds like a sort. So we made this guess that it's a sort. Now we're going to write a quick GDB script to find out if that's true. All right, I'm going to exit out of this, and I'm going to show you GDB scripting. There's a video, I forget which video at this point, but there's a video for GDB scripting, I think on this module, and I highly recommend you watch it and learn. But here's what we're going to do. We're going to write L4.gdb, and thank you. And we are going to break at every iteration of this script right here, of this loop, and at every iteration we're going to print out the entire input. Where's our input? Our input is at RBP minus 11. Here, this is what keeps getting referenced, and RAX is that counter. So let's go over here. We break at rebase. I have no idea how this will interact with pwn.debug. We're gonna keep trying to disable ASLR in GDB, but it is tricky. All right, 1493. Commands, and here we're gonna print out RBP minus OX11. The whole string. All right. What the hell happened here? Sorry guys, my keyboard is going a little crazy. Okay, so let's do this. Requires the target program to be active, so we just say start. All right, so when we do -x, it'll load in the script and launch every command in the script. This is a really awesome way to do dynamic reversing. You write scripts to dump information you want, and then you print it out. Oh, someone's asking if I can show the GDB file again. Here it is. Exactly what you would type into GDB. Start, you do a break, but here's an advanced usage of GDB. You can add commands to be always executed every time a breakpoint is hit. I could do that on the command line too in GDB, by the way. But it's easier once you start writing these functions and so forth. It's just easier to write them as a script. All right. So if we scroll up, did it not actually set it? Okay, we're gonna have to move this outside of the container because oh, no, it said. Okay, awesome. So if you do info breakpoint here, it shows you we have a breakpoint, breakpoint 2, that will print out the string at every time. So now if I just hit continue, and I scroll up, dude, Connor, why does pwn debug? All right, I'm going to disable pwn debug because it's messing with my scroll back. Pwn debug is messing with my scroll back. We're going to do just a very simple there. This disables GDB pausing, waiting for me to hit enter. This sets the history save to be on, and this sets the correct disassembly flavor. And now I have the rebase problem. All right. We're going to look into this rebase problem. In the meantime, I'm aborting doing this in the container and just transferring the program to my machine, where I have a fixed so now here I have a fixed base at this address. That is going to be awesome. Okay, I don't know why it had been there. Gonna delete pwn debug for a second. Okay, cool. So GDB-X. I didn't copy the level. And now instead of this rebase, it's going to be base plus. Awesome. All right, GDB-X. Oh. L4. Baby rev level 4. What? Oh, OX. Oh, sorry, guys. Okay, so I have my breakpoint 2, my breakpoint 1. Now I can continue. And I forgot to copy over my input file. Okay. All right, if I hit continue, see here's the breakpoint. It starts out, the data starts out as 546789AB. Hit it 1, it goes to 456789AB. Still 456789AB. And then it checks and says wrong. So that's pretty interesting. One interesting thing is that it did something in the beginning and then it didn't do anything afterwards. Why is that? Of course, we can take a look here and we can see that actually if the 2 bytes here, if this byte is already less than this byte, it skips this whole situation. All right, so let's break here and see which 2 bytes are being compared at 1400. All right, now we're starting to roll. God damn it. We look at L4.gdb. Forget about this breakpoint. Let's make a new one. Base plus where? It's going to be 1400. Awesome. Base plus OX 1440. Commands. We're going to want to see what is in RAX. And we're going to see what is in RDX. And then we're going to end. Okay? So now we do the same gdb-x. Hit continue. Oops. We've messed up. We did examine instead of print. So examine tries to dereference. It treats RAX and RDX as a pointer. We don't want that. They're just actual values in there. All right. Hit continue. We start out with 4 and 5. And what is our check? Our check, of course, is that RDX is less than RAX. Right? So this is a little confusing. Let's see if we can clean this up a little bit. This is me going off course, and it's probably going to go badly. We can do printf about to check C less than C, RDX, RAX. Will this work? No. Commas, not spaces. Oops, I forgot a new line. Okay, so now this you can start seeing, like, you can write very useful scripts here in GDB script. About to check 5 less than 4. Okay, obviously 5 was less than 4. About to check 5 less than 6. Where the hell did that come from? Let's re-enable our old checkpoint breakpoint here. Okay, so we started at 5, 4, say blah, blah, and then we did about... Okay, it's annoying hitting continue every time, right? Fuck that. Anyways, we can actually do continue in our script to just make this a printing breakpoint. Okay, let's continue. All right, so here we go. That was 5, 4, 6, 7, 8, 9. It checked 5 against 4. Then it checked 5 against 6, 6 against 7, 7 against 8, 8 against 9, 9. And you remember that every time it was checking, if this was less than, it does the swap, right? So we can actually get even more. We can print this guy here. So we'll print the state of this of our string, and then we can print this. And actually, we can also do printf state of our string. BP minus. All right, let's just do it all at once there. Boom. Continue. Oops, I forgot a new line. Always forget the new line is printf. All right, state of our string 5, 4, blah, and it's checking 5 against 4. Boom, it swapped it. Now it's checking 5 against 6. Okay, it's checking 6 against 7. So it's going through, iterating through the string and checking it. We have left Binary Ninja behind long ago. How awesome is that, right? And you can just see that it goes through, and it looks like it started out 5 against 4, 6, 7, 8, 9 to A, B, and then it started 5, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9A, but it didn't do A to B. So that's interesting. It iterated a shorter amount of time. This time it didn't even look at A. That time it didn't even look at 9. So it's just iterating one less. And what it's doing is it's comparing every 2 successive bytes and swapping them. It's a bubble sort, right? It's moving the highest byte value all the way to the end. It doesn't have to look at it anymore. That one's sorted. Then it looks and moves the highest remaining one all the way to second to end, and so forth. It's a bubble sort. And what we want is for that bubble sort to end up passing this check. Expected result is B, C, 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 F, G, I, P. Notice how that is sorted. Very cool. Okay, so now, where does it start at? This 4, right? So obviously these first are gone away. So we have B, C, C, F, G, I, P. We need to have our input sort into that. What's an easy way to have our input sort into that? Just put that in as the input, right? Basically turns that sort into a no-op and launch baby rev level 4 testing 1, and it says wrong. So let's do our GDB again. Why did it say wrong? 5 B C C. Oops. Sorry, we didn't start at the 4, we started at the 5 because we swapped the 5 and 4. Okay. Oh. Actually, now we don't need to do this. Let's just run it. Oh, fuck. Guys, why do you wait until saying something? Come on. There's a million people on Twitch here. All right. Or on whatever on. Okay, and we run it. Boom. Here's our flag. This is a fake random flag I have locally, but of course, if we copy this into our pwn.college site, by the way, you can write scripts you want to execute like this instead of actually SSHing in and doing stuff. This will be sufficient. Boom. Oh, that's funny. Because of buffering, it printed the flag first. Anyway, let me just SSH in and do this normally. Boom. Again, that is my specific level 4 flag. Don't steal that flag. Get your own. All right. So what did we do there? We looked at the binary enough to understand memory locations and a vague idea of what's happening. We didn't understand that it was a sort. Not yet. We wrote a GDB script to dump out memory. Let me show you that GDB script again, because GDB scripts are very, very useful. You can do arbitrary things with GDB scripts. Very, very advanced stuff, right? Already, this is super useful for this problem. We can make very useful GDB scripts for Yan85, very useful GDB script for the rest of the program, of the course. It's very good stuff. GDB scripting is super useful. And then by tracing that, we understood dynamically what was going on. So whenever people have been emailing me and saying, I don't understand what's happening on level 8, testing 1. And I say, did you trace it in GDB? This is what I'm talking about. Do this exact thing. And make sure you understand step by step. I wanted to show 2 more things, but we need to start the collaboration hour because we only have 1 hour left in the class. So maybe we'll show them Connor's office hours. One thing I already showed in office hours last time. Go back and watch my office hours where I talk about how to define structures in Binary Ninja, right? It's not useful for these baby keys, the level 0, level 1 through 10, but it's useful for 185 for Yan 85. Go back and figure that out. Watch the office hours. Figure out how to create structure so that you understand Yan 85 a little more. What am I thinking? The other thing I wanted to say is another good strategy. I mentioned OpenTTD, right? OpenTTD, by the way, amazing game. You should all play OpenTTD today. Well, if you don't have any other classwork to do. But aside from that, Transport Tycoon, the way that they wrote it, they took Transport Tycoon Deluxe, a DOS game, closed source, blah, blah, blah. They disassembled it. And they literally took this type of output and created a C program with this type of output. You can do the same thing for Python or some language you're familiar with for this code. You can actually paste this insanity. You can yeah, sorry, I wasn't showing this. That's why I sighed. You can copy paste that insanity into a text editor and fix it up so that it is valid Python code, and then step through it and understand everything in Python rather than C, rather than assembly. It might be easier to work with, right? You can use that to understand it, and now and then figure out how to solve it. Okay. I feel like there's something else I should mention. So three general strategies. 1, combine static and dynamic analysis. It's useful. 2, create types. Go back to my lecture hours on my office hours on Monday to see how I create types to make Yan 85 much more reversible. 3, there was a number 3. If in doubt, try to re-implement things in Python. This also actually goes for Yan 85. Yan 85 is actually a very simple VM. You can implement that whole logic in Python and give yourself basically an emulator to play around with. All right. Let me enable collaboration hour, and then we will resume question and answers for those that want them. Edit category. Okay. Enable everything. Okay. Collaboration hour is live. Yep. Everyone pile into your preferred collaboration hour channels and start tackling them. We will release new challenges hopefully tonight. Like I said, when we write new challenges, we have to solve all iterations, all possible iterations of them, because every time that we have taken shortcuts in the past, we ended up with unsolvable challenges. So we're not taking shortcuts this year. Instead, we're just not sleeping until they're all solved. So before we release them, we have to write all these verification scripts. We're still working on that for the new challenges. All right. Any other questions? Oh my God! Team Sandwich is the channel of the week again. Oh, Swarm is swarming though. Someone asked level 14 collab. Yes, it's collaboration hours. If you want to collaborate on level 14, do it. Someone on Zoom observed that Open Transport Tycoon scales to arbitrary resolutions. Yes, in fact, Open Transport Tycoon not only scales to arbitrary resolutions, it also supports multiplayer play. How cool is that? All right. Question on Zoom. Are the grades reflecting right now, still reflecting as if the assignment was due at 4 p.m. today? Connor? Yes, we forgot to fix the deadline. Ignore those grades at the moment. They will be fixed shortly. Sorry about that. Also, the grades don't yet, of course, take into account. Wait, Connor, is the makeup now properly weighed? Okay, awesome. Yeah, but the grades still don't have the extra credit, but they will. So Connor's telling me that if the binary has the SUID bit, then ASLR will not be disabled, even in GDB. Even in GDB. So what's the solution? To copy it elsewhere? This is awesome. All right. So earlier we rage quit the server because we couldn't disable ASLR. Now apparently we didn't have to do that. If I just copy this to slash, or well, let's do slash home CTF slash chal or whatever. Okay, let's do okay, yeah, let's do GDB chal. Oh, let me re-enable pwn debug. Yeah, very interesting. Ooh, I've never seen this so easily exposed. So I can move this around, right? So let's move. Okay, let's change it to that. All right, now GDB chal. Did it work? Maybe. All right. Anyways, oh yeah. Duh. Here we go. So, in order to disable ASLR, you need to move or copy the binary away anywhere else, and then it'll all work. Yeah. That's crazy. That is crazy that it doesn't care. Someone's asking, are other architectures than x86 coming in future weeks? There's a slight possibility of non-x86 in the combo modules, but the course is predominantly x86 and the on85. All right, let's see what we got. Wow, sandwich is half the class. Guys, you should spread out. I mean, why not? No, wait, torch is half the class. What happened? Sandwich is dead. How is sandwich dead? Sandwich was half the class. Damn. All right, we got some good good collab going on in Swarm. No one's going live. People should go live. All right. Well, I'm glad we got to the bottom of the the base address thing. That it makes it was not. Yeah. Yeah. It's a new feature in Ubuntu or whatever kernel Ubuntu 2004 uses, I guess. That's insane. It kind of makes. I mean, yeah, it doesn't make sense as a protection measure if you're running it in GDB and sudo is ignored, but it makes sense that it wasn't caught because this seems like a very, very niche use case. So Connor asked me, how does it lose its sudo bit if GDB launches it? It's a good question. If I had to guess, this is a guess, is that if you... Wait. How does GDB launch it? Yeah, let's see what happens if we strace GDB bin true, for example. Oh, actually, no. Let's do strace-f. All right. And we hit run. And my terminal looks like a disaster right now. Gonna put the output here. Okay, run, enter. Okay, it ran and exited. Then, all right, so let's look at sig child. All right, here's the child exiting. So here's the fork. There should be an exec somewhere. Okay, here's the ptrace me. Wait, what? Let's try as root. Yeah, that seems to have worked much better. Okay. Here we go. Child exited. Here's the various, some good ptracing going on. We didn't do strace-f. Okay. Here we go. Here's some personality stuff, no randomize. And then the fork. Yeah, this is when GDB forks, I think. Then, well, hold on, it still doesn't work. Oh, I see. No, this is because Connor, here's what's happening. strace is tracing GDB. Sorry, GDB forks, and then it tries to trace itself. It fails because strace is stracing, yeah. So I don't think I can actually observe what GDB is trying to do. Yeah, I think we'd have to use something like BPF trace. But let's see if this is if this is different when we run bin true, or I guess when we run. Oh, it's just ignored. So the personality call still happens, but it's hold on. Let's make a GDB. Make a GDB script to just run and quit. Oh no, that's we want it here. Okay, that's what happens there. And if we do baby rev, it just silently fails. Huh. That's not very nice. All right, let's. Well, yes, exactly. Yeah. It is not failing. I agree, but it is not having an effect. But I guess it makes sense it's not failing because right here it is still just doing a personality on its own. Right? It's not has nothing to do with this set UID stuff yet. Yeah. Okay. Someone on Zoom saying, "Can you please show the environment thing again?" Yes, I can. So, env is a program to look at your environment. If you do ASDF equals FDSA, SDF is the name of the environment variable, FDSA is the value, and I hit env, you can see that it shows up in my environment. Where is it? Oh no, it shows up right there. So here's where I launch the command. Here is the environment. In the same way, for level 3, I had an environment variable named SN. Did I not log out? Ah, shit, I didn't log out properly. Let's launch level 3 again, testing 1. Okay, assertion NP failed. Let's launch level 3 testing 1 in a binary ninja so I can get that. Oh, here it is. Yes, okay. It's smndf is the variable it takes. smndf equals something / baby rev. And now instead of saying I didn't give it the argument, just says wrong, no flag for you. Then the follow-up question is, how do you join the collab channel? The collab channels are in Discord. Oh man. So Connor, in one of the collaboration channels, someone is posting disassembler output from or debugger output from this is amazing. Yeah, for Yon 85. That's pretty good. All right. All right, people are going live on the collaboration challenges. I love seeing that. Such a cool way of collaborating in CTF. You know, in the COVID age. What are these like robot emojis on? Interesting, fascinating. How do we get cool emotes? Oh, we need to become affiliates. Oh yeah, that's Mr. Pog. Damn. All right, question on Twitch. Do we think there's a way to get the correct window size on the browser terminal so that Tmux works? So Connor reports that it's broken and he needs to figure out how to make it actually work. My advice, you know, that terminal is good to start, but the further you get into this course and hacking in general, the better it is to start SSHing. SSH is now on every. You can just run SSH on your Windows terminal. It's amazing. And B, use Linux. So Connor mentions that your firewall might block stuff like SSH if you're in a restricted network. So that might be then you have to use the terminal. Yeah, so we'll try to get that working. I'm trying to remember the other thing I committed us to do. Oh yeah, the CTF write-up flares, Connor. We gotta do that. I haven't been keeping a list, but it's all in our emails. So Magnetic on Twitch. You can put multiple public keys in authorized keys. You don't have to keep swapping them out. Oh shit! Never mind. I take it back. The website only allows one key. It's noobness on our side. Yeah. Oh man, yeah. So we went into live. We did a live beta of pwn.college. Launched that HitCon last year, and it made it onto Hacker News. And then people were flaming us for all sorts of reasons. Actually, one that we weren't doing like network security, but we were doing application security. But what can you do? Can't please everyone. And then two, because we at the time only allowed RSA keys. And which is still true, actually, and people were pretty upset that this is a noob move. But you know what? We're noob moving. Exactly. I think my headphones might have just died. That would not be good. Someone on Zoom say something. Connor, can you say something? Yeah. Hold on, I have to stop the screen share for a second. All right, Connor, can you say something now? All right, now it works. Amazing. All right, let's screen share again. Linux life, man. What is that, Connor? Oh, so Connor asked me earlier today. I was looking into GDB GUI. This is a cool thing Connor found, which is a web GUI for GDB. No, I was actually looking into that for this class, Connor. Just ran it real quick to see how it worked. Yeah, so what just to catch everyone up on stream, what we were thinking about is adding more buttons to this interface. So there's Binary Ninja, but then another button to just spin up a web UI for GDB with the program running, another button to spin up like Jupyter Notebook with a PwnTool script drafted, stuff like that. The problem, let me show you what happens with GDB GUI. So here's Baby Rev level 3. What? Let me kill whatever else is running there. Dude, the new 32-bit PIDs in Linux are really weird. Just do PSAUX on a modern Linux system. All right, so if you look, here's GDB GUI. So this is the UI could use a little bit of work. I mean, you can always do GDB commands directly here. So that is, oh yeah, because it's up. All right, let's dismiss this walkthrough. So we can start, and here we are at main. So we can do whatever commands here in this. So this is the GDB window. This is just the log. This is the program output and input. And then here we can like click around to look at memory, set memory things here. What is this actually? Create an expression, then click. Ooh, never. So here's a couple problems. One, without debug symbols, it doesn't seem to read registers here, Connor. Two, if we then say, okay, so we can fix that by manually putting all the registers in here. All right. Why is it all of this? This also doesn't seem correct, right? But let's switch it. Base 16. Oh, okay, never mind. That is correct. Okay, base 16, base 12, base 14, base 16. Okay. Copy to clipboard. What is this? Show XY plot. That's cool. All right, so we can manually start doing this. Of course, it has this useless local variables tab for us because without debug symbols, there's nothing we can really do here. And then if we go to, let's add RDI. Oh shit, no, RSI. Okay, RSI. So we can click here. And then I don't know how to dereference this further, right? So there's got to be something. I guess we can always do this. We can always cast it to unsigned char star RSI star star. This is argv1, right? Okay, unsigned char star, and then this is unsigned char, and then this is RSI. Okay. But then base 2, base 4. I like cycling between arbitrary bases. That's nice, but yeah. Yeah, there's just like a little bit of UI to be desired for just raw binaries. I think this is like undergrad project. We should hire someone to do it. I should look like what it looks like in Tmux. Oh man, I don't use Tmux, man. I mean, okay. Let's take a look. Control D? Oh, I was gonna say what? Okay, hold on. Let me just undo all of this. All right, let's just start fresh. Okay. So I launched Tmux first. Oh my god, this is so. And let's GDB chow. What happened? Nothing happened. It's the same. But this isn't custom. How do you know it's yours? Oh no, you hooked my mouse. Oh, you monster. I like seeing the, you know, the pipe when I'm over text, but now it's not a pipe. Damn. Seriously? Whoa. Huh. Yeah, probably this in a browser would be better than GDB GUI. What is this IPython? Just IPython for fun or what? Why not? I guess you can do import string and stuff. Yeah, I wish, so I can zoom out even further, but this is probably unreadable on Twitch, right? Or on any screen sharing. Yeah. Yeah. Because really, this is the optimal size of, but this is a disaster. Yeah, I think it's not a bad idea. We should really have write up like a, you know, or a video on the different tools available. Yeah, I guess xterm.js is still very relevant. Interesting. Yeah, let's update to the latest version. Magnetic on Twitch. I rewrote my whole config. Don't worry. I undid my crazy change for GDB init. It's back to normal. Damn. Okay, let's see. My Zoom chat got closed. Okay. Let's see what they're streaming. Cool. Live streams going on of level 14 in the collaboration hour. Can you maybe go over level 11? I'm still confused on what byte I need to change. Yeah, so let's take a look at level 11. All right, level 11. Let's grab level 11 testing 1. Launch it up in practice mode. And inspect it in Binary Ninja. All right, level 11. Go to main. So here's main. One thing I'm going to do right now is I'm going to enable the option show opcode bytes. So this is main with the bytes that are in the actual in the binary, because of course this is disassembly from binary code, which is just ones and zeros in your L file, right? And as a reminder, if we go over and SSH into level 11, tells us, hey, you can change any offset 5 bytes, right? 5 bytes in the binary, you can change into whatever you want them to be. Okay? Let's take a look how this works. And of course, why do we want to change the bytes? If we kind of keep going here and just give it the 5 bytes, it says, unfortunately for you, the license key cannot be reversed. Why is that? That is because the license key used is MD5. And you're not going to break MD5. Don't break MD5 for this challenge. It's the intentional solution is to use this ability to do these byte modifications. So you are writing a patch for a program to disable the license key check. Okay. Let's see. So we scanf for the offset. We scanf. So let's name this offset. Oops. No. God damn it. Where is it? Okay. Scanf RDI is there. RSI is this offset. And so here we have the offset, and here we have the new value. So we move the offset into EAX, move that into EDX. We move, then that's not ever used before again. Oh, okay. And then here we move something else into RAX and then add our offset to it. And then we dereference our offset and write the new value byte into that from DL, which came from ECX, which came from the new value. Okay? Fairly straightforward, if a little convoluted. What is var A0? That's the remaining question here. Var A0 appears to be the location of something in the binary ANDed with FFFF000. What this does is, let me jump into here. This is a good thing to look at dynamically. So let's copy this out so that the setUID bit is gone. Let's do chal. Okay. So now we GDB chal. Sorry, I'm fading. GDB chal. All right. We do break at start. Okay. Let's step until we hit this 17AF. Okay. All right. Let's continue. So now we're at 17AF. If we look at what is going on here, we're about to, we got the address of bin padding, some local, a bunch of NOPs for some reason in our binary. And then we are ANDing it with 000. Let's take a look. What is an RAX? Okay. This looks like a binary address. And let's step. And now we ended with 0, 0, 0. Okay, this is the base from which you can Connor, we got rated. Damn. All right. This is the base that you can, from which you can offset to modify, right? So then it'll add your offset to that and then do the write. Let's see what this is. Info proc map, or since we're in a fancier thing, VM map. All right. So we have we can do anything after this 5555 555 000, and that's right here. Right. Let's look here. This is basically everything that is in the code segment. It's the executable segment of this binary. Boom. We can write any bytes there. So what this is saying is you can patch the program. This is a crack me or a patch me challenge. That by loading a patch into memory, you are supposed to disable the license key check in this program. And then the question is, how do you do it? You can modify any 5 of any of these bytes, and these are the bytes in the file that disassemble to disassembly. If you modify these bytes, then you modify what this disassembles to. So now you have to figure out what to modify. It's just like shellcoding, except for you're replacing data that is already in your... You start with a template that is the binary, and then you can modify it. Hopefully that helped. How, Kieran? All right. To the raid that just joined us, welcome to pwn.college. A couple of questions popping up. What the hell is this? This is pwn.college, also known as ASU 466. If you go to pwn.college, that is an actual URL. It'll describe everything. The TLDR is that this is a course normally at ASU this semester, also at ASU, but also since things are online due to the pandemic, we figured let's just make it open to everyone online to learn. This class, of course, has these live streams. The live streams are then archived to YouTube. So these are our videos on YouTube. On YouTube also, we have actual lectures. These live streams are just typically question and answer sessions, live demos, things like this. The learning material meat is on YouTube, starting from basics such as, actually we expect you to already know the basics, but we do a review of the basics, of the fundamentals, like what is an ELF file, what is assembly, etc. And then diving into different concepts. The concepts that we cover in the course are the concepts we've covered so far are program misuse leading to privilege escalation, like set UID and so forth. Really, it's more program misuse than privilege escalation. We should probably rename that module. Shellcoding, escaping sandboxes like chroot and so forth. We are currently on binary reverse engineering, and we are next launching the memory errors, memory corruption module, and then we move on to stuff like ROP, dynamic allocator misuse, heap vulnerabilities, kernel exploitation, and automatic vulnerability discovery. Like I said, every module has a bunch of lectures that are online and available. You can just click through and then go, obviously to YouTube, and the lecture slides are available as well. And they have a bunch of, every module has a bunch of challenges that we wrote. You go to challenge instance, there are lots of challenges. Well, these 100 are just, but there are a lot of different levels with multiple variations of challenges per level that you can use to practice your skills. There's a global scoreboard. Every week, ASU races against, students at ASU race against each other and students outside of ASU. This week, we had our first week where someone outside of ASU took first place. So it's an exciting time. When you there's a question of what is the tool chain. When you spin up a challenge, you can spin it up in normal motor practice mode. We can get into that later. You spin it up, you can open it up in a tool called Binary Ninja. Nice and easy. You can also download it and open it up in whatever tool you want. These are all binary challenges. And then you can also click terminal or just SSH in, and you have a terminal with all of your normal Linux goodies like GDB and so forth. Question, is there a time limit to take this course, expiration date before it resets? We'll probably reset it. So the course runs once a year at ASU, so we'll probably reset it again next August. But we keep everything that is, for a reset from last year. It wasn't really public last year, but we still kept all of the modules we used from last year up. So archived modules. We'll probably have an archived set of modules for 2019 as well. Yeah, so this is this course is created for to torture our poor students at ASU. That's Arizona State University. What we're looking at doing for the future is creating like an earlier stage course that'll teach you, go through the fundamentals that we expect everyone to already know, that we just review at a very high level. But, I think a course that goes into, C programming and how that maps to x86 assembly exactly, and how Linux works on a deep level would be interesting for people. All right, let's check in on how the collaboration hour is going. Oh, still people collaborating, but starting to drop off. So we'll probably end the stream in about 3 minutes. That's the end of the scheduled time. And then we'll end the collaboration hour probably 15 minutes after that. And then from there, everyone is on their own for the challenges. Until office hours, of course. So Connor will have his office hours on Friday. Connor, did we figure out a time? Is it the same time? All right, Friday at 2 p.m. Connor's office hours, live streamed here on Twitch, and then also will be archived to YouTube. Awesome. People are collaborating. That was great. On level 7 testing, can you show an example of printing the string in the buffer right after the read in GDB? Let me see. Let's see what level 7 testing, my level 7 testing does. Spin it up in practice mode, open it up in Ghidra, in Binary Ninja. All right, jump into main, see what it does. Ready to receive your license key, and then it does an LSeq with the first argument of OX346, Let's take a look at what lseek does. Well, I mean, obviously what lseek seeks in a file, but the first argument is a file descriptor. So, boom, right off the bat, we can see that this challenge reads from file descriptor 346. Let's see. Okay, yeah. So 346. Let's see it for me. It'll be different for you. Let's see how we can talk to it. Of course, if we sh in. And we run it, no flag for you. We s-trace it, we can see that is whatever that the hex value was in decimal, and it's bad file descriptor. All right, how do we give input to this program? We give input to this program. There's a number of ways we can do it. The easiest way is a bash redirection. You can, of course, redirect standard input. Let's say I wanted to, well, you can do it in multiple ways. You can pipe. Gosh darn it, this doesn't have my bash config. You can do this, and this, of course, redirects it to standard input. That's file descriptor 0. Unfortunately, we don't want file descriptor 0, we want file descriptor 838. How do we do that? We could, of course, also redirect this way to file descriptor 0. So let's say here's our input file, and then we can do our input file like this. Same sort of thing. Of course, we still don't want file descriptor 0, we want file descriptor 838. Turns out this can take arbitrary file descriptors in bash, which is incredible. If you do 838 less than, we are now redirecting it into file descriptor 838. And here we are. So then how do we do this in GDB? Here we have GDB. If we want to, if we just run it, oops, GDB with the, let's copy this here. All right, now GDB chow. I copied it for those that weren't paying attention earlier because it has set UID on it. If I don't copy it, then it will very frustratingly not re-randomize the address, de-randomize the address space. So ASLR will remain on. Okay. If we run it, okay, it's trying to. So if we break on lseek, we run it, and we see the arguments. Again, RDI is, here's that file descriptor number. And this is kind of a bummer, right? Because how the hell do we input stuff? So if we actually step over, we're in lseek right now. If we let lseek finish, okay, now we've returned back to main, and we see in RAX, it's a -1. lseek failed because that file descriptor wasn't open. We do run with our bashism. I have doubts that it'll work. I haven't actually tried this. I did a lazy other thing. Where's my bashism? Okay, whatever. Let's just get the lseek there. Okay, here's our file descriptor. This needs to be decimal. Okay, we're in lseek where our breakpoint was. Let's let it finish. RAX is negative. Okay, no good. We still had the same issue because GDB doesn't redirect input like bash does, right? And we can actually show you if we call getPID inside the program. It's PID 84. If we proc 84 FD, Unfortunately, GDB ignored my 838, or more likely used that as argv1 and then redirected input to this. Okay, so that's annoying. So what do we do? Well, there's an easier thing to do. We can do this redirection to file descriptor 0. Now we're at lseek. Fuck it, let's just make RDI 0. Let's make it read from standard in. You can set RDI equals 0. We just reset that to 0. Continue. Of course, standard in is still a problem. Or sorry, the f read is still a problem, but we can do both. Let me just write a quick GDB script. So as a reminder, let's see what it does in Binary Ninja. It'll lseek and then it'll read. And that's the last time. So let's do this. Let's take a look at that read in GDB chal. Let's break lseek, break read, run. We first break at lseek, then we break at read, and then we're done. So now we can do a very easy script. Break lseek commands. Let's fill this. Okay, set rx equals 0, or sorry, RDI, the first argument. And do the same for read. Done. Now we can just input stuff over the command line. We do gdb-x script.gdb chal. Here are 2 breakpoints. Run. Oh, shit, sorry. And then let's, of course, just continue from that. No reason to keep us occupied. Boom. So now we have a GDB script that breaks at the input, redirects where the input is coming from, so that we can easily do this, and then continues. Why is this frozen? It's not on the TTY. I did not expect this to freeze. Okay, let's we'll do this. We'll go. Okay. Okay, so first call get pid. Is there an easier? Oh yeah, duh. Okay, is there an info FD? Oh, proc info. Yeah, duh. Okay, yeah, so that works. Okay, good. So let's where are we right now? We're in lseek. Finish. Okay, lseek works just fine. Continue. Now we're in read. So let's step up to the syscall. Okay, this is on the syscall. Reading from file descriptor 0 to here with OXOC. Success. And I bet, yeah, we're in main. Everything is good. I bet we just can step all the way through. Yeah. All right. I don't know why it didn't work with these continues there automatically, but I guess we can just do this. Run, continue, continue. Oh, it waited for me to hit enter. Yeah. All right. Yeah, so let's just do this nice string.printable. We'll use that as our input file. So we can also figure out what bytes are being read from where. gdb-x run, continue. Still waiting for me to hit enter. So it's still using file descriptor 0. Oh no, thank you. Continue. Yes, okay, sorry. It must have been that all those times that it wasn't working, I wasn't redirecting standard in. Let's modify my script so that we do continue here. Continue here. Oops, run. No, still, now. You're right. And it's, hold on, I have to SSH and kill it from outside. The fuck? Okay. There we go. Right. Yeah, see? That's hilarious. Still. It has no explanation. All right, we're not going to delve on that. We'll just, the hacker way, just do what works. Continue. Okay, that works. We just hit continue twice. It's not a big deal. All right. Now what? Now we have input. So now let's do our typical trick of adding some functionality to print stuff out. So here, this is where we check the received license key against the expected result. This is where we do some sort of a loop. And this, if we zoom out, looks like complete insanity. Oh my God. This is... Oh, okay, yeah. So this is where the first mangler is. That's the second mangler. Basically, things just look like bad news. But what I'd like to do is break here, and at both of these locations, we will just print out the our input bytes. Actually, for that, let's figure out where our input bytes are. Our input bytes, as if you remember, there's this RAX that it seems to be used as a index into our input. My guess is RBP plus RAX minus hex 15 is some index into our input. So RBP plus hex 15 is going to be where our input is. In my variant, and yours it might be different. So here, let's break at base plus. We'll break at both of these loop headers. 1383 commands printf. The string is RBP minus hex 15 and you know what, we're gonna YOLO and hope for the best here with a continue. And then we are going to do the same thing at 1440 right here, the second loop header. Okay. Let's give that a try. Oh, error. Argument arithmetic operation. This base address. What's our base address? Yeah, there. Need to set the base address. There. Okay, let's do this. No more errors, except for this split mind insanity that Connor does, but okay. All right, then we run with the input. Okay, continue, continue. Why does it hang? Why does a C? This has to be some pwn debug stuff. Let's disable pwn debug for the time being. Just the important part. Disassembly flavor Intel. Set history save on. Set height 0 so it doesn't keep in everything else. All right. Run. Input. Continue. Continue. Yeah, it was some pwn debug stuff. All right. So here's the string dynamically. Magnetics, if you're still there, we managed to get away from this get away from the crazy file descriptor input by overriding the FD used. Don't forget, you're not just an observer. You control this program when you're in a debugger. You can make it do anything you want. You can call arbitrary stuff. You can actually call open 1,000,000 times in that breakpoint to open the right file descriptor. You don't have to just change RDI. You can do anything. And then here, it's just the same reverse engineering dynamically, right? So combination of this output and the the disassembly, you can understand what is going on. In mine, of course, everyone is different. In mine, it seems to be swapping characters here. So it swaps K and 9, and then it swaps J and A, and it swaps I and B. So it looks like it reverses the string completely, right? So we start at 9 A, B, C, D, E, F, G, A, and then we have that backwards, 9 A, B, C, D, E, F, G, H, I, J, K. So it first reverses the string, and then it does some crazy stuff. So this is non-printable characters, so I probably, and it does something very uncomfortable to all of the characters. And I probably need to print out, of course, the hex values of these instead of the ASCII. But then using all of this, I can reverse and understand what's going on. Ah, yes. So, yeah, in the breakpoint, you see these args. When the breakpoint is hit, those args are still FD838. I only changed them after the fact. I could also, by the way, let me just show you an insane other solution. I can comment this sane solution out and make an insane solution. We break at lseek, and then we do open, call, open, input, 0, and I do this 8,000 times. Oh, Connor's right. We can call dupe too. Man, dupe. What? Connor, what happened? Yeah, all right. Dupe2 is an awesome awesome system call that will just take your old file descriptor and duplicate into your new file descriptor. And he's right, this is much, much easier. So we can do call dupe2 old to new 838. And this should return 838. All right. Let's do this, gdb-x, run invalid character and expression. Oh yeah, I'm not at C, I'm in GDB. Let's see if this works. Oh, it works. And now if I do info proc, oh, info proc info. Proc info. Oh, I'm not here anymore. Okay, that's fine. We'll do this. Does this work? Yes. Okay. ls-l/proc. I vaguely remember that it would work. Here it is. 838. Boom. And now you can just continue and it all works as well. Watch points. Yes. Watch and then a memory address. Yes. Oh, interesting. Yeah. So I'm going to show one more thing on Connor's suggestion. We're going to show how to set a watch point based on a memory location changing. So let's see how this works. I haven't used watch points in ages, so this is YOLO. If you do start, okay, watch points are breakpoints on data. These might really slow down your execution, by the way, because most of the time this has to be done with single stepping, but that's fine. Most of the time it's fine. All right, so watch RBP minus OX 15, and then let's just continue. Oh, wait, hold on. We still need to do the input thing. So let's get rid of these things that print out our data. Okay. Start, watch, run. Oh no, continue. All right, it's happening. Wait, shit. No, I'm watching the value of in RBP. Start. We have to watch unsigned long star. So this will watch 8 bytes pointed to by RBP minus 15. Let's run. Boom. Does this look familiar? I don't know why it's you. Oh, that's just okay. That's the first time. We continue. This has some. Obviously, it's gonna have a problem every time you're not in main. Eventually. Now, oh yeah. See, so. It didn't hang. It was just slow, and obviously there's a lot of false positives. But we can actually do something more intelligent. Start. Let's see what RBP minus OX15 is. Actually, let's step in just so we are sure that we're done messing with RBP. Okay. Here we do the watch point directly on this value instead. Oh, my history didn't save? What the hell? Oh, you did. Yes. No? Yes, there. So you do the watch point on this. Hardware watch point. Oh, that's better. Okay. Here it got zeroed out. And it's reading in what, byte by byte something? So let's see. No, something didn't work. What if we... Oh, yeah, because we didn't... We didn't actually run anywhere. Shell1 error in source command. What's wrong with our source command? Oh, sorry. 3 hours on stream is tough. All right. We have our script with our breakpoint to fix up the input. Whew. Now we do our watch point. Watch. Let's actually do this. Let's see if this works. Char star RBP minus 15. No, not RBP minus 15. This guy. Oh, fuck. Where's our old watch point? This guy. Okay. Continue. Run. Okay. Continue. No. Okay. Ready to receive your license key, LSeek. Okay. We have a K. No, we messed something up again. Alright. We're not going to keep debugging on script on stream because I got to run. But using watch points carefully, you can also help yourself a lot with this. As you can see, watch points can be a little tricky. If you figure this out, maybe we'll talk about it in office hours, for example. But as yet another tool in your toolbox. Awesome. Okay. Anyone have any final questions before we roll off? And we'll give Collaboration Hour a chance to wind down. We'll end it at 8. All right. If not, we're going to end the stream. Thank you for joining. Hope to see you all again, especially some of our raiders next time. As a reminder, all the lectures are online in kind of digestible chunks. I highly recommend watching them before diving in to these extended Q&As. We're on stream Wednesday, 4:30 to, it looks like, 7:45, but usually 7:15. Monday, 3 to 4, and Friday, 2 to 3. See you next time. Good luck on the assignments. Ciao.